right, welcome everyone. This is quite a group for today's discussion, so thank you so much. I'm Lydia Mashburn. I am with the Graboyes Center at George Mason University. We're delighted to be a part of today's conference, looking at 3D printed prosthetics. It's been an incredible day. I'm just amazed with the people I've met and the panelists. It's just been a great discussion about people helping people and how technology has enabled us to do that. So today now, this afternoon, we'll be talking about the public policy implications of technology and 3D printed prosthetics. So we have a great lineup today. A few of our Graboyes scholars and a representative from the FDA, which we're delighted to have here today. We'll go over some brief introductions and then we'll get started. With us is Adam Thierer. He is one of our senior research fellows. He's in our technology policy program, and he specializes in technology, media, and the internet. His latest book is called Permissionless Innovation, the Continuing Case for Comprehensive Technology Freedom, which we had copies out earlier today at our booth. They are all gone, but if you would like a copy, please come see me afterward and we can connect you. Following Adam will be Richard Williams. Richard Williams is our Vice President for Policy Research. He is an expert in benefit cost analysis and risk analysis. He was Director of Social Sciences at the Food and Safety, Food and Drug, at FDA, but you were in the
Center for Food Safety and Applied Nutrition.
Yes, and he was there for 27 years, so he's our in-house expert on all things regulation. And then we have our scholar, Dr. Robert Graboyes. He is a health economist, and then which you all got to meet earlier today. And then after that, we have Lieutenant James Coburn. James Coburn, I love, I'm going to introduce his entire department within which he works in, because I just think it's very, very cool. He's principal investigator within the Functional Performance and Device Use Laboratory of the Division of Biomedical Physics in the Office of Science and Engineering Laboratories at the Center for Devices and Radiological Health within the FDA. So, I think to sum up, though, he gets to play with stuff for his day job. Actually, yeah. So we're delighted to have these panelists with us here today. And so without further ado, I will introduce Adam.
Thank you, Lydia. I appreciate it. Appreciate all of you being here today. Again, my name is Adam Thierer. I'm in the Technology Policy Program at the Graboyes Center at George Mason University, where I cover emerging technology issues, mostly those flowing out of the internet and information revolution. So that's really what I want to talk to you about today. And my brief time with you is just to sort of set the stage by talking about what we can learn about the future of 3D printing policy by looking at where we've come in the debate over the internet and information technology. Because really what's happening today is that 3D printing is about to witness sort of a replay of what happened with the birth of the internet and information technology markets. We're seeing this sort of same explosion of innovation and creativity happening, built upon the so-called collaborative economy or peer-to-peer economy or sharing economy model, where people can come together and through decentralized, distributed sharing of knowledge and information, just unlock amazing potential that went untapped in the past. There are countless sectors and professions that have been absolutely revolutionized because of the internet. But what really is amazing about the internet and the information revolution is the fact that it's allowed average people to come together and made it easier for them to pool their knowledge and their passions. And when they were able to do that, amazing things happened. We saw that with the internet, of course, and now we're seeing it again with 3D printing. So first, let me just ask you to recall how the internet story unfolded and what makes it so amazing. I mean, first and foremost, most obviously, the internet and the information technology revolution. These are not my slides, by the way. They're sort of bouncing up there. Let's not do distracting. The internet and information revolution basically gave us access, most obviously, to just more goods and services than we've ever had before, through increased specialization for diverse needs that the public had. And that created all sorts of benefits for society. But the really powerful part of the internet revolution is that it provided us with more and better information and made us more fully informed and empowered consumers and citizens. And that creates better functioning markets or self-regulating markets. And it created, in the process, really powerful feedback mechanisms. We now have the ability as a society to talk back when we don't like the way things work in a way that was really almost impossible when some of us were growing up in the old days. We have powerful reputational mechanisms at work, rating systems and feedback mechanisms, community self-policing, information forums, hobbyist sites and groups. And all of the combination of these functions and factors enabled trust to develop online. It enabled us to do things that were unthinkable in the past, like making remote connections and engaging in remote commerce with people we never saw who could live thousands of miles away. I first experienced this firsthand, trading, buying and selling cars on eBay. Interacting with people, big money items I'd never met in my life. We were able to do that because of the reputational feedback mechanisms created by eBay. We were able to rate each other and find out if they were trusted vendors, trusted buyers, so on and so forth. And so we now see that in a smaller way in the sharing economy with things like the rise of Uber and Airbnb and all of those different types of services. So that's the sort of story of the internet and all the wonderful things that it's provided us with. It's solved a lot of those informational asymmetries, is what economists call it, that we had in the past. We just lacked information to be more fully informed of how we're consuming. Now we have it. But we need to step even further, one step further back and ask, now, how did that happen? What enabled that world to come about? And the answer is that we got our policies right for the internet. We got our defaults right in the sense that we embrace the idea of what I, again, call in my most recent book, permissionless innovation. We embrace the idea that people shouldn't necessarily have to go out and ask before they go do interesting, innovative, and even risky things. We just allow them to go do it. And that really broke with the past, especially for an information or a communications technology. Because if you think about it, the internet was really the first major modern communications or networking technology that was sort of born free. Traditional things like broadcast television and radio and cable television, these things were sort of born in captivity. They were more heavily regulated, licensed, permission. You had to go say, can I please be a broadcast? Can I please be? With the internet, we said, no, you go do it. And the way we accomplished that is that we got some policies right in the mid-90s, the Clinton administration in particular, by basically allowing for commercial development and interactions on the internet. And then we also made sure we had a sort of a light touch approach to getting our policies right with regards to internet, even though there was obviously some concerns. So basically, we allowed for permissionless innovation to take hold. Essentially, innovators were, if you will, innocent until proven guilty. You were allowed to go out and do things, and we waited to see if there was actually any sort of harm. Stated differently, America rejected what is sometimes called in academic literature a precautionary principle approach. We rejected the idea that you needed to have sort of a mother may I permission-based approach before you went out and innovated. The precautionary principle mindset basically is based on the idea that, well, there's risks associated with new innovation, and before you go out and innovate, therefore, you should make sure that no theoretical bad cases could develop, no harms could develop at all. The problem with that, of course, is if you spend all of your time basing your life and basing public policy upon hypothetical worst-case scenarios, then best-case scenarios can never come about. So we rejected that thinking. Other countries embrace more precautionary principle thinking for the internet. You look at the way Europe regulated the internet and approached it, far more precautionary in character, very concerned about how the internet would affect various societal values or legal principles. As a result, it's very hard today to even name too many major innovators in Europe. Most of Europe's major internet household names are American companies. And that's not a mistake. That happened because we embrace this idea of permissionless innovation. Now, why should you care about this? You should care because, again, we're seeing this whole process play out again with regards to 3D printing. 3D printing will create boundless opportunities for society, but also create some serious challenges along the way. You will threaten existing institutions, existing norms, and sometimes existing laws and regulations. I would still argue that we should embrace the idea of permissionless innovation and avoid sort of precautionary principle-based policy, and avoid the idea of thinking just because there's some chicken little scenario out there, a hypothetical worst case, that we have to regulate all activity or all technology to solve that narrow problem. The better approach is to look for better solutions, to use education, to use empowerment, to find ways to communicate to the public about risks, and then talk about how we solve the hard problems that develop after the fact. Obviously, 3D printers can be used to make a great number of other products, some of them potentially even dangerous. Certainly most of you are familiar with the battle already going away about things like, can you 3D print a gun? And all the other types of things like that. But that shouldn't stop us from allowing innovation to happen for all the other beneficial services that are out there. So again, I'm going to, since I'm well under my 10-minute time, I'm going to leave some time for my colleagues to talk more about this, because what they're going to do is they're going to put some meat to the bones on this and talk about how this sort of battle has already played out in other contexts, at other agencies, and is likely to potentially come to play out here in the world of 3D printing. So thank you, and I'll turn it over to Richard Williams.
I'm low-tech. Even at a high-tech conference, I had to go low-tech, so I have notes. Okay, so I want to follow up where Adam left off on the precautionary principle. And with a quote, the fatal flaw of the precautionary principle is the unsupported presumption that an action aimed at public health protection cannot possibly have negative effects on public health. And that is actually, I think, where I want to focus my remarks, that one of the things that we really need to do more of is we need to examine these trade-offs between allowing something on the market that would be good for you, that actually makes us safer, and preventing something from coming on the market that might do us harm. And too often, we don't actually recognize that that, in fact, is a trade-off. And one of the things that we don't do in this country is we don't go and look at our regulatory agencies and say, wait a minute, let's see what's been going on for a while. Maybe we should review the mission of that regulatory agency to see if things have changed, and so perhaps we've changed the mission. I'm formerly of FDA, and I can tell you that FDA is now 108 years old, and there never has been such a review of whether or not FDA's mission should change. And I'm going to argue that I think that it should. And you can't change the fundamental issue of the FDA by tinkering around the edges. You can't give the FDA more money and expect them to go a whole lot faster, or you can't change the president, because that's not how it works. This is in FDA's DNA. So, let me tell you a story about my side of the FDA. I was in the food section, and this will give you some idea of how it works. Congress gave FDA the authority to regulate dietary supplements, you know, the vitamins, minerals, herbals. And they said, you can regulate how they're manufactured, but you can't regulate the ingredients. I said, okay. And so I was tasked with, all right, go find out what the problems are and how dietary supplements were manufactured. We looked for a year, and I mean we looked everywhere. We could not find any problems with how they're regulated. So I went to the person in charge who had already pretty much written this regulation, and I said, look, we can't find any problems here. Let's just drop this regulation. And her response to me, I thought, was telling. She goes, but Richard, we have to get these guys somewhere. And that's really the philosophy. Everything has to be regulated. We have to get these people somewhere, and it's important. You may not know this, but FDA regulates 25 cents of every dollar that consumers spend. That's a huge mission, and that's the philosophy. All those things must be regulated. The problem is that FDA is almost charged with ignoring the unintended consequences. By unintended consequences in this area, I'm talking about what we call risk-risk analysis. So risk-risk analysis is sort of every time you try to regulate one risk, another one pops up. Everybody know what whack-a-mole is? You whack one mole and another one pops right up. That's risk-risk analysis. So, for example, if you tell people they've got to do a lot of paperwork and testing before to ensure that a product is safe and effective, some of them will just give up. If you tell them that they have to clear every marginal improvement through an agency, that product may never be improved. And the reason that FDA, in essence, can't worry about these problems is because FDA mostly worries about the seam. So if a product goes on the market and there's a problem with that product, everybody can see that. Unfortunately, everybody says, well, that's FDA's problem. FDA let that bad product on the market. Okay? So FDA naturally is going to be concerned with keeping things off the market that might be unsafe. What they're not going to be concerned about is things that didn't get to the market or got to the market too slowly, and all the people that were harmed because they didn't have that product. Because that's the unseen thing. So what does this do? Well, we've seen this in other areas of FDA. FDA has pre-market activities on food and color additives, on drugs, and medical devices. In food and color additives, I can tell you, one of the first things that I heard about, that I was most concerned about, is manufacturers would come to us and say, look, we don't even know how long it's going to take to get something to market. What happens is we submit some tests, that we think the tests are definitive, but then somebody comes along and says, well, you know, maybe that's not so definitive, we do another one. Or we get working with a regulator, and the regulator says, if you find X on a test, you know, you'll be approved. That regulator retires and goes somewhere else. We get another person in, and they have an entirely different philosophy. So we never know. And that uncertainty was a problem. FDA actually tried to solve that problem. They wrote something called the Red Book, and they said, here's what happens if you do a certain number of tests, and here's what's going to happen to you. We wrote the Red Book the last time I checked, was around 2000. the average time for approving a food additive was 6 years. So uncertainty is a problem, time is a problem, and certainly you know this. And I'll talk a little bit more about this. If it takes too long, you miss first mover advantage, and that's a huge problem. And obviously, the cost of submitting things to FDA is also a problem. So within medical devices, and I hope Jim will correct me if I get some of this wrong, but I think I got it right. Unless you happen to be exempt from a regulation, there are 4 categories that you can go into. And exempt medical devices is, I'm not kidding you, a manual toothbrush is exempt. So you don't have to get clearance from FDA if you want to invent a manual toothbrush. Pre-market notification, or their 501Ks, and that's if you have a product that you've invented that's similar to something on the market, you can submit your information to FDA. Interestingly, though, it's called pre-market notification, but you can't go on the market until FDA gets around to sending you a letter telling you it's okay to go on the market. If you invent something brand new and there's nothing like it on the market, you can apply to FDA for a de novo determination, say this is brand new. You actually have to prove to FDA first that there's nothing like it on the market. And then FDA will make a risk-benefit determination of whether or not your product is safe and effective. That's for those are for moderate risk devices. If it's a high risk or a novel product, it actually has to go to pre-market approval, and that you have to generally do a clinical study on those. And FDA has a lot of authority over those. They can recall or suspend the marketing of those devices. Finally, there's a humanitarian device exemption intended to benefit patients with rare diseases or conditions. Again, though, you have to submit all that information. And, of course, you have to register your facility with FDA, and there is a cost for that as well. So most of these provisions that set up these classes were set up in 1976, the Medical Devices Amendments. That's 40 years ago. There was a few changes in 1997 with the Padama Act. But 40 years ago, a lot's changed since then, and I'm going to build on some of the stuff that Anna was talking about. Changes in technology, changes in knowledge, and changes in international competition. So Adam talked about technology. Think about what's happened in 40 years with the web. Okay, this is like living in an alien world, like Bob mentioned this morning. Think about 40 years ago, if there was a problem with a device, what would have had to happen? Well, somebody would have had to think about, well, maybe I should write a letter to somebody, and maybe that goes to FDA, and maybe some letters come in over time, and then they say, well, gosh, there's a problem here. Maybe we should do something about it. Not anymore. If there's a problem, it goes out on the web right away, and there's already private market alternatives. So, for example, the Brookings Institution has set up the National Medical Device Post-Market Surveillance System. So these things are feeding into a database. People find out right away. So what happens is if there's a problem, one of 2 things is going to happen. The market knows about it right away. People stop buying these things, or maybe what we heard today is people will actually quickly improve the product, maybe solve the problem. And if you don't, you run the risk of suffering the cost of recalls, brand name diminution, or actually a lawsuit. There's another thing that the web does. We have this crowdsourcing issue that goes on. Remember, every time there's a medical problem, there's an opportunity for medical innovation. So every time there's a problem, what happens is people can get together and solve that problem quickly. And that I think is one thing that will be really serious. So going back to the high-risk things for which you have clinical trials, I found a really interesting quote. Today's best clinical practices are most often derived through randomized clinical trials or expert opinion. But neither approach addresses even a small fraction of the scope and complexity of patient and clinical variation that occurs in the real world. That is, with crowdsourcing, you can get much more information much more quickly, and this is better than what we've considered the gold standard in science. Thank you. Another thing that's happened is we know much more about safety than we used to. We used to think that safety was a static concept. So FDA says, this is safe or it's not safe. In fact, in 1988, 11 years after the Medical Devices Act, Aaron Waldowski said, it's not a static concept. We have to search for safety. We have to learn over time, and that's what you're talking about. You find some problem and you solve it. It's a process, not a condition. However, FDA can frustrate that. In FDA's guidance, they say all changes to a device design will require some level of design validation or evaluation that assures the device continues to perform as intended. Another thing that we've learned is we're a lot different than we previously thought. We know now in drugs that we're getting down to individualized drugs for individuals. That one pill for an entire population doesn't make sense. Our bodies are a lot different than we think. But in addition, we also found out that we have sort of heterogeneous desires. I think I heard today that different kids want different kinds of hands. FDA sort of acknowledges that. They say, well, FDA would consider evidence for them making a decision relating to the patient's perspective of what constitutes a meaningful benefit. So my question is, if everybody has different demands, and there's over 300 million consumers, why do they submit all those sort of different preferences for risk and benefits for FDA to make a decision? Doesn't it make sense that the consumers who have different preferences should make those decisions? In fact, FDA admits it. They say the decision as to whether or not to implant the device is a matter of patient preference, perhaps with the involvement of the physician. One more change that's really serious is international competition. Between 1950 and 2000, the level of international trade increased by 22 times, and since then it's increased also dramatically. If you're not first, if you lose that first mover advantage, you miss the opportunity to get your brand recognized, you miss that opportunity to generate customer loyalty, and you also miss the opportunity to perfect your product or service before other people come in. We are much slower than Europe, and there are many other countries around the world that are much slower. This is a system that has to change. When we asked people who made medical devices, 9 out of 10 of them said, yeah, the FDA is a problem in that respect. So what do we do? I think there are 3 principles that we can look forward to. First of all, let's have a preference for consumer sovereignty. If the risk is low, since we know we're getting faster information, we can pull products off the market or we can fix them faster, let's leave it to consumers to do that. We also know that consumers have different preferences. Second, let's separate out safety and efficacy. Efficacy was a late addition into the regulatory field. Now, sometimes efficacy can bleed over into safety, right? If something doesn't work and it causes you irreversible harm, I agree, let's keep that in. But other than that, let's leave efficacy to consumers to decide. Does this work or not? If it doesn't work, somebody's going to fix it. So we get a lot more innovation that way. And I would agree, where probability and severity are still high and you get irreversible errors, I think we do need pre-market approval. But as long as we do these other things, if we separate out, we have FDA focus mostly on safety, as long as for low-risk products, we have, as Adam would put it, permissionless innovation, that gives FDA the ability to just concentrate on those few things that really are potentially very harmful. And so I think it's time, after 108 years, to go back and revisit the mission of FDA and make it more in line with the 21st century. Thank you.
So first I'll ask, how many were in my morning talks on repeat and how many weren't? So about half and half. There will be a little repetition. So I think the really important lesson, at least for me, I said this morning, I don't know if people here are aware of just what an important story this is. It's not just about 3D printers and prosthetic hands. It's about the future of healthcare. It's about the next 25, 30 years, where we're going to go, and how you take this spirit of an e-NABLE, where you've taken amateurs, you've taken a carpenter in South Africa, introduced him electronically to a puppet maker in Washington State, put it onto YouTube, seen a mother of a 4-year-old in South Africa ask, can you build a hand for my son? And watched it transfer around the country, around the world. How can you take that sort of rapid-fire movement and the rapid-fire innovation and apply it into other areas of healthcare? It's obviously a delicate situation. I think the great thing about this is it's a window into possibilities. And clearly, when you're getting into more complex, more dangerous areas, pharmaceutical development, more complex device development, issues arise that don't arise with e-NABLE necessarily. Although I will note that, as was Troy this morning was noting, there is looming out there the possibility of legal actions that have to be thought about. You think, so let's think where we are. So there were $40,000 hands, and all of a sudden, a year and a half ago, we started getting this proliferation of $10, $20, $30 hands, which in some respects aren't as good. Okay, the hands that are being built out there are not, they don't do all the things that the $40,000 hand are. On the other hand, can't escape that. You can build one for a small child who you know will outgrow it in 3 months, 4 months, and you can buy another one. And if it gets broken or lost or stolen, whatever, you don't have to worry, well, it's the last that we have, we run through the money for that. In that respect, it's arguably a better product along some dimensions. My guess is that if this is allowed to continue in its current configuration, the sort of spontaneously developed hands like this will ultimately, and probably not in the long distant future, exceed quality in most respects of those $40,000 hands. And I suspect the manufacturers are aware of that. If you think about it, you go back to 1965, computers, there were very few of them in the world, and those that existed cost millions of dollars, and they filled up a room, the size of this room. Now, you can be a small child in a third world village carrying an iPhone that is more powerful than any computer that existed on Earth, not just in 1965, but so I've heard in the mid-1980s. However, what you really needed at that time was you sort of needed a duality. You had a spontaneous market, Steve Jobs working in his garage and Bill Gates dropping out of college to start his company. You had this, again, very much e-NABLE type folks developing computerized, let's say, information technology products. At the same time, you did have the giants, the IBMs at the time, Honeywell, and other companies that were building the mainframes. So there was this side-by-side development going on, and you probably needed both sides of that. So I suspect you need the $40,000 hand makers, and you need e-NABLE, and somehow the combination of that is what will get us where we want. John was talking this morning about the two hands being apples to oranges comparison. I would say it's apples to mainframes. So, good, it worked. Now, what's also amazing in this is you get evolution. It's just to a startling degree. If you look at what's happened in a year and a half of developing these things, so you end up with Luke's hand with 2 thumbs. You end up with hands that are slimmer, more natural looking. I don't think it was in the e-NABLE network, but there was a story on the internet about a fashion designer in Savannah who designed an absolutely astonishingly beautiful hand for a classmate of his who he just walked up to on the sidewalk and said, "You don't know me, but I'd like to build you a hand." The one who had a longer arm, day glow, comic book superhero. These things are important. You think of how the Apple developed and began to encroach in mainframe territory. It did not start out as a little tiny mainframe. It started out as a toy. You played games on it. You drew pictures and you did funky little things, and no one exactly knew what you were going to do with it. And it was that process of developing strange, random processes to do on the Apple that eventually turned it into, I'm sitting here watching my iPad click off, and that iPad, which will do things, as I said this morning, that someone 25 years ago would have assumed was pure science fiction and not within the realm of possibility in their lifetimes. So what's the basic lesson here? I think there's kind of an iron law of innovation that says if you restrict innovation to insiders, to people who have the credentials, to large institutions, you will never get the sort of breakthroughs that are represented by an iPad versus a mainframe. You somehow have to let that breath of fresh air and the strange people you've never heard of coming in with the innovations that just knock you apart. And the strange collaborations, again, it's a carpenter and a puppet maker who did the trick on this one. And similarly, why is the apple what it is? Because Steve Jobs took a calligraphy course in college and said, okay, when I build my computer, I want it to do graphics very well. So much of innovation is just random chance where we've been. And to a large extent, the way we have designed our healthcare system, going way beyond prosthetic hands at this point, is we have shut out that spontaneous process. We have created a process where everyone involved just about has to be a highly credentialed insider, and often, and someone my age, I can say, someone whose great achievements were 20 years ago, but may not be quite at the top of the game at this point. Whereas if you look at computer apps, you're seeing, you see 15-year-olds become billionaires in a couple of years because of, again, this random spontaneity of it. And as I said this morning, and I won't go through the whole talk again, it would have been very easy in the 1980s to shut off the development of the internet, and we wouldn't have e-NABLE today. So where's this going to go? We've heard little allusions, some from my co-panelists here, some from other speakers. We're on the verge of we're on the verge of having 3D printed organs. We're on the verge of being able to, and it's already actually beginning, sending little nanobots into your bloodstream to repair damaged genes and keep you alive or keep your mind going longer. Molecular medicine. Richard talked about safety and efficacy. Interesting little book that Adam recommended to me a couple of months ago that's become one of my favorites, called The Cure and the Code. And there's a discussion in it about how you cannot demonstrate any drug for AIDS to be both safe and effective, because the organism evolves so rapidly that by the time you got through with traditional FDA trials, you would be dealing with an entirely different species. And it's not that we don't have statistical methods that can deal with that, it's just we need to deal with a different way of looking at these things. So, where do we go? People ask, so what's the solution? And I'll say, I don't know the solution. I know sort of how you get to the solution, which is we open our minds and start thinking about changing the way we do business. Maybe parts of the FDA should do certification rather than allowing and disallowing. The funding formulas perhaps different. I had a conversation out there at the table, and I've had it before. Someone asked about federal funding for innovation. As I say, I'm not dogmatic on it. There are places where that's entirely appropriate. I'm not sure we're using the right models. I was talking to a group of academicians, the whole room of which was highly in favor of federal funding of innovation. I said, here's the problem. The federal government, when they want to do grant reviews and award innovation grants, they hire people just like me. I've got a PhD from a prestigious university, and I've got a long track record in academia and whatever, and I know how to write whatever. I said, but I've never taken a huge risk in my life. I've never run a company. I've never patented anything. I've never developed an idea like that. I don't know how you do it. I sort of, from an academic sense, but I really, it's not innate to me, and yet I'm the sort of person who's doing this. Does that mean the federal government should be out of the business of providing innovation money? No, not necessarily. Some places, perhaps, to that extent. Well, maybe we need to look at different models. I was up on Capitol Hill recently talking to a congressional staffer about perhaps shifting from the traditional review to offering prizes like the X Prizes. You look at, for inspiration, things like Kickstarter, that maybe there's some way to rebuild the funding mechanism that looks somehow more like that. So, I guess to sum it up, what we don't want to do is try to restrict innovation to a hothouse, a greenhouse, an artificial environment. If you, it's just like tomatoes. If you try to do it in a hothouse, you're not going to be the most flavorful. And the question is, how can you safely bring in the sort of genius of random collaboration that you see here into these other great developments that are going to happen. And as Richard alluded, if we don't loosen these things up, if we don't allow it here, other countries are going to do it. Just as an example, if somehow the FDA were to say no more e-NABLE pens, somebody would go to the Bahamas with a $2,000 printer, print them, and buy some envelopes. A lot of these technologies are simply not going to be stoppable. And we're probably not adequately preparing for some of the more dangerous prospects. For instance, we are on the verge now of being able to 3D print pharmaceuticals. And there are envelopes, and so we need really to think of this new world rather than looking backwards into an old world that we've had for a long time. That's for me.
Hello, everybody. So there was a lot there. I'm not exactly sure where to begin. I have a few things that I was going to say, and I still will. Most of my experience at the FDA is on the technical side as well as the regulatory side. As you mentioned, I'm at the Center for Devices, so I'm actually at the center where we look at medical devices. And I agree, there are a lot of interesting parts of our regulatory process that have started in the 1970s and unfortunately without an act of Congress cannot be changed. So I think, Mr. Williams, you're the one that was mentioning, who do you write to? Congress? That's who you write to? That's actually true. If you really want to change something, that really works. Because we can't, we can't either, unfortunately. Because once it's law, we've got to do something about it. I will make a few, I guess, embellishments or additions to what they were saying about the classes of devices and things like that. Some good news and bad news there. Good news is most prosthetics are Class 1 exempt devices, which means that they can be placed on the market without regulatory review. They have to go through registration and listing, as was mentioned, which I believe is a fairly nominal fee. I don't actually know the fee for that. But once you're registered and listed, you can basically produce that. If you're a clinical institution, then you don't have to do some of that either. You don't have to comply with some manufacturing GMP, good manufacturing practices, because clinical institutions are exempt from some of those. All of this information is actually found on the FDA website, so I'm not telling you anything that you can't find on your own, but the website is not the most user-friendly. I wouldn't call it Web 2.0 just yet. We're working on that. The other thing is that, so the next level up from that is these Class 2 devices, and those devices are based on, classified based on actually this 1976 Act. So if you were born before 1976, basically you're Class 2, because that's what they said. And since then, we've been using a risk-based approach where you have a certain amount of risk, we evaluate that risk, and you are cleared for marketing. The fee for that is actually fairly low, it's about $5,000. So unless you're a small business, in which case it's $2,700, unless, of course, it's the first time you've submitted something to the FDA, in which case it's free. So go at it. 97% of the medical device companies are actually small businesses with less than 50 people. So it's an industry that has quite a lot of small business innovation. And I like to think that we help to enable that rather than facilitate that, though I know at times it does seem like there's a lot of regulatory hurdles. And those are based on some of the technical concerns that we find with a lot of these products. And a lot of these products, as were mentioned, are not just the prosthetic hands, it's not just the toothbrushes and tongue depressors, things like that, which are obviously very low risk, but are, you're talking about stents, you're talking about deep brain stimulation, possibly gamma knife medical radiation therapies, and things like that. That ratchets up the chain a lot higher for the amount of risk that each of these has for the patient, for the operator, and then also the benefit that those things have to the patient. So some of the things I wanted to talk about were the technical concerns and activities that we are looking at 3D printing. One of these things is the crowdsourcing, and so we are actually really excited to see what's going on here with the 3D printed hands, 3D printed upper limb prosthetics, and it's very cool to see how fast the innovation happens. One of the things that we're looking at as well is that online, when you look at these download sites like GrabCAD or other sites, you can find a lot of other things that are crowdsourced, so to speak. I looked the other day and I saw a knee implant. So if you're going to have a bum knee, then you could cut off parts of your knee and stick this in, and you can have a knee implant. I would not recommend using one that you can get off of GrabCAD. It is very bad. Just saying. I mean, I'm sure the student had a great time designing it, but it was not a great one. Just looking at it. So there are these aspects to crowdsourcing and innovation that we try and balance, as they say, it's a balance between the risk and the benefit. And where does the patient want to have the risk, or where does the patient know enough to take that risk, and then where does the clinician have a real perspective on that? Because the clinician knows what a knee implant should look like and knows what a knee implant should do. Patient doesn't necessarily. So those are some aspects of the higher risk devices. What we're seeing a lot in those kinds of more traditional manufacturing areas is there's actually a lot of 3D printing innovation there as well. So we have already cleared several 3D printed devices through the FDA. There's most of them, I believe, are in the orthopedic space, so knee implants, hip implants, things like that. And a lot of this kind of falls into, I'll say, 3 different buckets. One of them is that they're making an interesting design on their implant that you can't make with another manufacturing process. So it's, I'm going to go back to a knee implant. So say you have a knee implant where you're just putting the 2 pieces in the knee to attach the top and bottom of your leg back together, but they want the bone to grow into that. And there are ways of traditionally making it do that. But what they've done now with 3D printing is they can print a trabecular, a kind of porous bone structure that mimics your real bone onto the device. So now the device kind of looks like your bone to your bone, and your bone grows into it. It's a very cool thing to do. But you can't do it with any other method, really, because you just can't get that sort of intimacy and non-repeatable pattern like that. And we've cleared those through this Class 2 process. One of the second bucket would be patient-matched devices. So these are devices that you can modify slightly for each patient. So you have a template, and then you basically just work that template to make it fit your patient. And these are also cleared typically through the 510K process, depending on whatever the parent device is. So the benefits of these are that you can maybe reduce the amount of tissue that they have to remove, you can improve the fit, and it's much like prosthetics. So implants and prosthetics have the same kind of thing. The closer you match it to your patient, the kind of better outcome that the patient feels like they get from it. The last one is patient-matched accessories to surgery, or cutting guides and radiation delivery dosing devices. And these are enabling people to make sure that a surgeon can cut or deliver dosages of radiation in exactly the right spot for that person, because much like one pill doesn't fit one person, dosing radiation to a specific portion of the body isn't the same for every person, because every person's lung is not exactly the same size, shape, and spot as everyone else's, so that you need to really locate those things very specifically, and they use 3D printed guides to do things like that. So some of the, I'm going to say, technical considerations we've been looking at that apply to prosthetics are things like mechanical stability. 3D printing, as you have probably figured out if you're one of the speakers in the room, or if you're just a user of the technology, when you print in this layered fashion, especially with the filament printers, the strength between layers is much lower than the strength across the layer. And so when we're looking at medical devices, either the cleared devices for orthopedic implant or for, I guess it's mostly just ones that are cleared for implant, we're looking at the strength of that device, because if you print it in a different orientation, you've now changed the strength of your device. And this comes into play if you're making a prosthetic. Of course, like I said, we don't actually regulate, we don't actually review most prosthetics. We review some prosthetics, especially when it comes to the ones that are electrically activated or actuated, robotics, and the ones that are intracranially stimulated as well. But for the manually actuated prosthetics, we would really review those. But just so you know, it depends on which way you print these things. You have to really make sure you're getting the right direction. Otherwise, you're not getting the right strength, and you might just crumble when you're trying to pick something up that's a little too heavy. Let's see. What's the last thing? So the place we see this going is that we are really excited, the FDA, are really excited about where we see 3D printing going, because there's innovation in the implantable space, there's innovation in the DIY space, and this class 1 space, and right now, the way things have been reviewed, 3D printing has not, what we say, raised the class or up-classified any device yet. That means we're treating it as another manufacturing technology for an existing thing. If you come up with a completely new thing that you then also 3D print at the same time, then no promises. But if you're printing a Class 1 exempt device, then right now we have not up-classified anything from Class 1 exempt. And the technical considerations we have seen are not insurmountable, and we're working with industry right now. We have a workshop on the 8th and 9th on 3D printing, which I would invite you all to, but we actually sold out all, not sold, but all the spots are taken. We have 300 people, and we have a waiting list, which is great. It's mostly for the vendors, or the people who make the printers, the medical device companies who make some of these devices, and then scientists and kind of that I guess the hothouse of people. However, there is a webcast, so if you're interested in signing up on a webcast, basically look up 3D printing FDA workshop on internet, and that'll be the first link that comes up, and you can register for our webcast on that. And what we're doing there is we're trying to bring together all the people who do this all the time for a living and see what are their concerns. What are the best practices that they've already figured out to make sure that problems don't occur? And then we're going to try and implement that through our guidance process. So it's not a regulation that we can do, because that's kind of beyond our scope at the moment, but it's part of the guidance that we can give, and the communication and the outreach. And I think hopefully this is part of that outreach as well, and I look forward to I have a question now. Should I take it when we get to the panel? Okay.
We will now take audience questions, and I guess, which was the first one you saw? Raise your hand.
In my research, it seems to me that your simple 3D printed hand is a Class 1 device. However, if I go into a website, I see that any manufacturer of such a device needs to be registered.
Right.
Given that individuals are printing that, where is that stand? Does the individuals need to be registered?
Right now, I'm going to give you a right now snapshot. I won't say this is exact, because I'm not in the policy. I'm not in that group, so I don't want to say anything for them. But if individuals are printing these for their use,
For another child's use?
right, but not for. Basically, it's that line of, are you a manufacturer, right? And you become a manufacturer when you start selling stuff, or you start giving things broadly. And so if you're if you're using it for like personal use kind of thing, that is usually where that lies. But yeah, I think that's the best I can do. Lydia, you can.
Just lady here in the booth.
So my question is kind of a follow-up. Okay, so first of all, one, if not several, e-NABLE members coming to your workshop. So it's not like
Yeah.
e-NABLE's not going to be represented there. But then my question is kind of related to crowdsourcing. So there are already.
Still don't get that name.
What?
Still don't download that name. It's no good.
I wouldn't get that one. There are companies, small and large, already participating, in the e-NABLE community. And there will be new ones and more in the future, both in this country and elsewhere. But there will always be, I'm pretty sure, as long as it is, the community that has started so far, there will be a group of individuals that are absolutely committed to only doing this for free, on their own, like open knowledge, open science, open everything. And so my question is, and you kind of alluded to it just now, that the scope of the FDA, concern is, you mentioned marketing and it's from, companies, but then you also said, or you give away a lot. So is this part of what you're trying to figure out? I mean, there's a 3D printing world, which is a technology thing, but then there's the open communities and crowdsourcing world. And so I'm not sure which of those two you're tackling in your workshop or.
So the workshop is mostly the technical bit. So we're going
Okay.
to look at, material sourcing, how do you maintain material quality across a lot of these systems that they use for medical devices are powder-based, and also a lot of the things that they make into powder oxidize or basically rust very quickly. So if they're exposed to air, so you have, as opposed to a large block of, say, titanium, you've got a very, like the outside surface that has surface, as opposed to powder where everything is the surface. And then you're making that into a device out of powder. So those kinds of concerns, this direction of printing, the kind of the design envelope. This is somebody mentioned design envelopes, where this is the whole patient matching. So how much can you match something to a patient from your template before that is no longer viable, right? So if you have something made for a 250-pound, 6-foot male, and you warp it down to a 4-year-old, is that now still a viable application, because now all of your parts are very small, all of your intersections are going to be printed in a different way. So,
But do you know, or can you guess, the interest of the FDA or responsibility for like crowds of individuals that are doing this at scale? I guess that's kind of what my question is. It's just not clear if that's in scope or out of scope.
it's definitely out of scope of the workshop.
Right, okay.
As far as completely,
That's what you don't know.
I would add, and I want to echo something that Jim said. I think he's absolutely right. FDA receives a statute. FDA then has attorneys that interpret those statutes, and that drives what they do. You're in a new area here. You guys are creating a new area for them, and they have to figure out what to do. If you're concerned about the direction that that's going to go, FDA would not be the right place to go to. Go to Congress. Congress are the only people that can change that statute. And you have an organization already set up.
Maybe here in the front. I have a question in general about all prosthetics, not just e-NABLE, and a large part of regulatory is also insurance, which unfortunately is not really represented by this bill, but I have a question anyway, which is, from what I understand, you can only be reimbursed if you have a code for a certain product. So first of all, do you need another code for a 3D printed product? Or can you use an existing code? And second of all, how difficult is it to get the insurance company to create a new code for a 3D printed product?
Well, from my perspective, the coding problem is a problem in and of itself. It's a very cookie cutter sort of a process that's sort of artificially designed. So I suspect ultimately the way insurance is designed will change rather seriously. And that's a really interesting question. I mean, part of it too, you just encroached on the question Jim was just talking about, when the insurance is paying for it, it's now a sold product. It's an entirely different thing. I guess one of the, I'm going to segue because it's a very good question and I don't know the answer to that. That is something that probably an insurance person. I would say the larger issue is going to be, this is a spectacular, unique product in that you can make them awfully inexpensively and you can give them away. Two things. One, ultimately, I suspect, even though despite the enthusiasm in this room, the novelty of doing so will eventually fade. And I think you will have, if it is permanently a giveaway model, you may run into problems a few years from now when everyone's got a 3D printer and it's not a terribly interesting thing to have any longer. The other thing is some of the really spectacular innovations that are probably going to keep coming along are going to be a bit beyond the giveaway level of expense. If e-NABLE hands cost $500 in materials, I don't know that you'd be having the success that you're having. At least you would need a very, very different sort of a business model to do it. So I think, segueing off of your insurance question, the really interesting thing is how are we going to end up defining how insurers and others pay for these new products that do not fit any pigeonhole that currently exists in the medical system. And I'll just throw it out. It's a great question, and I don't know the answer, but I'm going to think about it more now that you've asked it.
As far as we know, insurance companies are not covering 3D printed prosthetics or
No.
any other sort of.
No, they're not.
We're going to go way back to that. Gentlemen here in the green shirts.
I said, maybe I'm off base a little bit, but the FDA, you mentioned you recognize it as a manufacturing process. The insurance reimbursement codes are not set on manufacturing process necessarily. If I machine a hip or I metal injection mold a hip, it's a product that falls into a reimbursement code. So I would think they're two separate topics, are they not?
We don't do anything with insurance as yet.
Right.
So yeah, we recognize it as a, like you say, as a manufacturing process as part of the existing types of devices.
Right.
Yeah.
The process itself of 3D printing is not something people think that the insurance companies.
There are actually, I mean, like we mentioned, outside of prosthetics, there are 3D printed products out there. Invisalign braces, we've already 3D printed. Some hearing aid cases are 3D printed. So, teeth, bridges and crowns and things. So there's actually there's a bit of that around, and I'm assuming they must fall under some insurance code, but I don't know anything about it.
Gentlemen here in the front.
I'll try to be balanced with my question here. Without the FDA and friends, you get things like people swallowing radium to cure all ailments and bloodletting barbers and that a mess. So I'm certainly in favor of some kind of government involvement. What I often see with the FDA is oftentimes they'll try to solve every problem with a hammer when that problem might be a screw. You get a lot of regulation and enforcement where an alternative tool might be public education. So obviously we want to make sure that all interventions are science-based and that the public is well informed about the services that they're getting. So I'm wondering if this unregulatable open source science might catalyze some sort of shift in focus from regulation and enforcement toward alternatives like public education.
I have a comment. Yeah, I spent a lot of time dealing with this exact issue on broader internet policy issues because there's a need for education to alleviate a lot of ills that are created by this massive interconnected network we call the internet. There's a lot of harms that could come out of it, so we can find alternative solutions. Sometimes law is the best solution, but many times it's just better education. So in this case, for the 3D printing community, I think, John mentioned this morning, John Scholl, that with great responsibility or great power comes great responsibility. We have to start ourselves in this community by educating others, talking about responsible use, talking about potential dangers of things that you can 3D print, even when they seem like they have innocuous, no harms at all. In the field that I spend a lot of time with internet policy, there's a lot of talk about security by design and safety by design. Ways that innovators themselves, developers themselves, can, at the very early stages of product development, think about ways they can make their products safer, more secure, or educate their customer base about how to use them responsibly, sort of responsible use policy. Doesn't mean they'll always follow that advice, right? And that's a problem. People can do crazy things with technologies even after you've warned them about them. But just educating your consumers, educating your community, having them come together and then educate others. Because when we talk about policy, we're spending a lot of time talking about FDA and Congress, but there's a lot of other constituencies to educate. You got to come together as a community because there's so many other constituencies, not just in Washington, but at state capitals and everywhere else, that will be making different options. So there's strength in numbers. You come together, you talk about how you can educate first and foremost. Then there's a totally different level of education, which is that maybe there needs to be education that the government can help with, having to do with not just responsible use, but with other types of safety concerns. So that can be public service announcements. It can be what's called media literacy or digital citizenship training, like here's proper use of these things. Here's how to use or how not to use these technologies, or use 3D printers in this case. That can be something driven at many different levels, starting with the developers in this room and at this conference, all the way up to government. In between, it can be trade associations. It can be like nonprofit organizations. I work with a group called Family Online Safety Institute, and they're actually now getting involved. I'm like, well, what do we need to know about 3D printing and like how children will use it? What are the dangers, the risks, and the benefits? And they're talking about that. So there's a group you could work with to talk about that. So education at every level is what I call the layered approach to safety, security, and privacy concerns raised by the internet and information technology. I think it can work with 3D printing as well.
I would add, it's not just education, it's information. So who here ever goes and gets a hotel in another city without looking online? You get hundreds of opinions, and you look at the opinions that matter to you, right? You make your own trade-off with hotels. With respect to the knee, I agree, nobody should have that. My guess is you go online and you look up, that knee, you're going to find a lot of people going, geez, don't do this, stay away from this. So there's a tremendous amount of information that's already out there.
Yeah, ladies, can I just add something?
Real quick?
Yes, one of the keys to your question is, the era when people were swallowing radium was one where there was virtually no way a person who's, you're sick, here's some radium, swallow it. There was almost no way that person could get any reliable information on, is this a good idea? Now there are vast numbers of places you can get it. And actually this came up as a really interesting question when they reintroduced thalidomide to the market. Because thalidomide is a miracle drug unless you're pregnant. And they put a fellow on the commission, the ethics commission, that was deciding, should we allow this? And he was one of the thalidomide babies from the late 50s. And he made a statement at the time saying, you know what, I know this will be misused. At some point, there's going to be another me, because someone who shouldn't be taking it is going to be given it. And he said, I feel my responsibility is to be part of this process, to say yes to readmitting it, and to have a very good answer to the child who's born with the problems I have, and to explain to him, this is why I thought it was worth reintroducing. And so, yeah, there are no perfect answers on either direction. Looking for the sweet spot is really what we're about.
Education, obviously, very important from all levels. So,
thank you. Yeah, I'm going to try to condense my question into just 2 parts. So first I want to introduce myself. My name is Jan Baum, and I run a statewide leadership initiative for the state of Maryland, raising awareness of 3D printing and additive manufacturing and facilitating engagement among business, industry, and entrepreneurs. We're statewide purview. Maryland has some great senators or congresspeople, elected representatives down in D.C., and both U.S. Senator Barbara Mikulski and U.S. Congressman Sarbanes have requested briefings with 3D Maryland, and we've done some really great events with them. So one of the questions to the panel is, how does Congress get educated? So that's one, and I'm going to throw my other part in there, because I think and I'm happy to talk about how we've done what we've done. We've done a lot of work in Annapolis as well. But my other question for you guys is, how does the U.S. regulation compare to Europe's regulation and other industrialized nations? Because it seems to me, as someone having some level of expertise in 3D printing and additive manufacturing, that we are behind. Would like to take which part first? Yes, go ahead.
So you asked, the first part was how do they get educated on it? Well, I can't speak to all parts of it. I know, so our lab does a lot of 3D printing. There's a couple of labs at the NIH. And Representative Sarbanes, as well as several members and staffers from the House Committee on Science and Technology have actually come and toured our lab specifically to learn a bit more about the technology. We've also had the Secretary of Health and Human Services as well as the Commissioner in. And so we are personally, personally in our lab sense, are taking it as a mission to advance this as much as we can through just education and getting people to know what it is and what the limits are of the technology. Because one of the things that we've noticed is the first question we get is, can you print a gun? Which you always like, yes, but make one from Home Depot too. So two is that you get these statements of like, oh, when are we going to print organs? And you have to kind of back people away from, like that's not tomorrow. Like, this is nascent technology, and that has been actually quite successful at getting their enthusiasm, and I think a little bit more of the understanding when you bring it down to that level.
I would just add that Mercatus has a number of programs where we do put on educational seminars on the Hill as well as briefings, and if you're interested, please give Lydia your information and we can talk about it.
And actually, moderator's prerogative, I'm just going to say I used to work on Capitol Hill. If you want to educate your Congress members, do not underestimate the power of showing up at their door. Like, they can't say no, they can't turn you away. If you are their constituent, they will treat you well, or they should be treating you well. That staffer should be fired. And you should be able to get a meeting with your representative, especially if you come in a group. Contact their office, ask for a meeting with your Congress members. Say you're bringing a group of folks in, you want to talk to them about 3D printing. So definitely be proactive. So there was that part about the international part, so I'd like one person to address that before I move on to the next
I
question.
can't add.
Go ahead.
Yeah, I was going to say that it's a fundamental problem, and not completely solvable, that in the FDA, for example, you have an incentive system that says if you release a drug and 10 people die, your career is probably over and you're in deep trouble. If you fail to release a drug and 100,000 people die because of the failure to release it, you're in a perfectly fine shape. There is this bias in that direction. I'm only beginning to understand how differently they do things in the EU. My sense is they are successfully rolling out drugs safely, more quickly than we are, because they've somewhat dealt with that by, rather than having an FDA, they have sort of multiple. The closest model we have here is underwriters' laboratories for electrical components and such, where you have the EU designates these independent agencies to do this work, and they have reciprocity agreements, and you can shop around for the regulator that you want to review your drug. And it probably is changing that incentive, that suddenly there's a stronger incentive to say, I actually need to get this out so all those people don't die.
Adam, did you have some comments as well?
No, let's go to the questions.
Next, the lady here.
So given the fact that we are looking at the impending regulation on the internet for net neutrality purposes and figuring that the information flow has sped up such that you would expect the regulatory cycle to speed up and catch up with the technology, what do you think we should be looking for in terms of trying to make sure that the principles of e-NABLE in terms of keeping the development open, keeping the community open and sharing, and yet still having room for industry, where should we be focusing on and trying to direct the work and make sure we have protections in terms of future looking where the FDA or other government agencies can try to regulate?
Well, that's a great question. It's something I spend a lot of time dealing with. One of my closest friends, Larry Downs, at Georgetown Business School, wrote a book called Law of Disruption. He said, the fundamental law of disruption of the information age is that technology evolves exponentially while policy evolves incrementally. And that mismatch tends to be growing with time. And so you see each of these new technological developments that are coming along today, not just in this field, but many others, always producing sort of a quick press release or a sort of techno-panicky moment with someone's hair on fire, and they're like, oh my gosh, what am I going to do about this? And then the next day it's gone, there's something else. So, there's a good question as to whether or not the law will be able to keep up the way it always has, which you create a specialized regulatory regime or legal paradigm to cover each new technology and its theoretical harms. I think what's happening with policy is that it's realizing, a lot of policymakers are realizing it has to evolve now at the pace of Moore's Law, the pace of semiconductor innovation, which is to say, every 18 months, semiconductors, double in power and the price pretty much falls in half. Can policy keep up with that? I think what policy has to do, and you've heard it from our other panelists today, is it has to be most responsive to the most serious problems, most serious harms, really zero in on those, and figure out how to handle that and be more accommodating with a dose of humility and flexibility with all these new technologies. Because you think about what's going to happen when 3D printing innovation is happening at the same pace you get your smartphone updates. Like every update is rolling on your phone all the time, like you got a new version, new version, new version. There's no approval for each of those new versions of these things. And I don't see really how that can happen in the world of 3D printing either. So what instead has to happen is that we have to communicate to our policymakers and regulators, you need to allow that to happen. And then we'll help you address the most serious problems as they develop. Don't pretend that those problems won't exist. Because there will be people who use 3D printers to make things that potentially create harm.
Next question, follow up on that one, which is, what do you think the most serious problems are
The 3D printers?
facing this particular
Well, we haven't just, guns. Absolutely correct. Go to don't talk about 3D printing on the quote, and there's, I think Chuck Schumer, Representative Schumer already had a bill dealing with this.
I want to direct you away from the manufacturing process to the issue of the manufacturing process for the prosthetics.
For the prosthetics?
Yeah.
So,
Let me just say, I appreciate it. She's asking a very specific question. What are the issues that people concerned about e-NABLE and its progress should be most attentive to?
I'll let these guys, we've already talked a lot about the FDA-related issues, but I will say we haven't spent much time here talking about intellectual property-related.
I would say take a look at the categories that you can fall in, the buckets. And just what Jim said, what you shouldn't worry about is not what happens right now. It's what FDA hasn't figured out yet. Since they haven't figured it out yet, that means there is a policy space where you can go to Congress and help them figure it out. Help them figure out what's low risk, what can the market actually handle, what can people handle between the patients and their physicians, what can they handle that perhaps FDA just doesn't need to get involved with, so we can continue this fantastic pace of innovation. Innovation sells on the Hill, they're very interested in that, and so FDA can continue to drill down on the really serious things that they should focus on. So now is the time. Look at those buckets and say, which one do you want to be in? And in a large measure, I think what you want is exempt.
There's one quick thing I can mention about that is, so usually a lot of the regulatory space changes with attributes, right? So, but really, this is going to take off my FDA hat a little bit, but I'm more like a standards hat because I work on standards committees, and some industries self-regulate through good practices and setting up guidelines and things like that. And one of the best ways to show that you are doing something that you know you can do and that there's not need for concern is to have a structure to show that you have already thought that through. And to disseminate that out throughout your organization and throughout, this is the education thing again, to everybody, so everybody understands what good practices are, and that really is just in general.
Next question?
So as we talked about here with the digital age and that with 3D printing, there's a proliferation of information, as I mentioned, with parts used on that, and also now a lot of products being prints. So might that, with the information, obviate the need on some level for FDA oversight? And if so, would the FDA, the culture and priorities of that institution, be willing to permit that? Might it be open to scaling back its authority a little bit?
So let me see if I understand the question.
Pardon me,
So the question is, would the amount of information that we now have about this allow the FDA to scale back its oversight?
So yeah, we've got a ton of products of 3D printing. We've got a ton of people reviewing these products and saying this is crap, this is good, this is dangerous.
Right.
So we're now crowdsourcing information and QA a little bit.
So it's the intersection of FDA policy and this new way in
Exactly.
which information is able to be transmitted among consumers, which before the advent of the information age,
Right.
we so heavily relied on FDA for that kind of information.
I don't know if there is an intersection right now, because I don't think we take into account a lot of that kind of crowdsourcing. However, like I said at the very beginning, is that, especially in this space with prosthetics, especially manual prosthetics, that are non-powered and non-robotically controlled, it is in this class 1 exempt space in which we don't actually review. So there's, all of the different prosthetics. I don't believe any of the prosthetics that were out there that I saw have come through for review. So there's still that space out here, and you can do what you're doing with this is critical practice.
Is there any chance that that type of information would feed back into other processing devices?
Right. In thinking about it, it was mentioned that we're reaching through like 3D print drugs and pharmaceuticals. I imagine maybe there's a community of people out there that would be interested in just trying that, which sounds frightening to me, like I wouldn't want to do that. But if that becomes the reality where it's easy to get your hands on experimental pharmaceuticals and things like that as a consumer, and also easy to review things, is there anything the FDA could do with that, or it sounds pretty less.
Well, there are a lot of experimental drugs going on right now.
Yeah. I don't know.
I think we have time for one or maybe two more questions. The gentleman here.
I understand currently you can just develop a device and be able to post to the internet, no regulatory requirements associated with that, whether if it's not for sale and it's not expensible.
Not entirely true. Yeah, there's, so that I'll give you the stock agency answer, which is that's true. So yeah, if it falls into one of the higher risk devices, then there's a whole set of things you have to do. But even class 1 exempt devices have a specific set of regulations attached to them. And yeah, I think it would really depend on the scale and if you're posting it to your personal page or to the e-NABLE site. Yeah, I think it would depend.
Because I guess the question sounds like if you public like firearms development, you end up violating like U.S. export laws. Severe penalties like that. And I don't want to be posting like a research project for aesthetics and end up violating.
I would recommend if you have any questions about that kind of thing, there's a department or agency called DICE, it's the Division of International Consumer Education, and they know the answers to these questions.
I'd say one of the things that we've hardly even touched on today that's really crucially important is we don't know the legal environment. If something happens bad with an e-NABLE hand, and one day it will, who's responsible, who's liable, whose pockets, we don't know, and I suspect that's one of the tasks you probably should face early on.
Time for one more question. Way back to that.
Well, actually, I was going to make a couple comments. One was right on that line, is where if we don't look at how the product liability could be associated to it, the relationship that could be fostered and really take off with the prosthetist and the community that has the experience in the fitting and can look at and consider that as one of those many options that's available for people, that's going to be pretty hard, because as long as that product liability is hanging out there, that's going to be really tough to cross. I think that to answer the question related to the insurance stuff, there's several things there. And, obviously you've talked about intellectual property. There is a lot of stuff out there that is similar to this that I have to watch for. But as far as regulatory coding and stuff like that, the codes are set up for features of a prosthetic device. They don't describe how it's fabricated. They don't even care a lot of it. It's just the features of how it works. Okay, so I don't see that as an issue at all. I think the real issue is, what are we going to do about the liability, intellectual property, and there's one that really hasn't even been discussed at all, is related to licensure of prosthetics. Because there's a lot of states that require licensure for prosthetists to be able to fit prosthetic devices.
Some more policy questions to pursue.
Yes. So it opens up another door.
For everyone. I think John would like to make a few closing remarks, or
Well, I was going to suggest that I think we are scheduled to break around now. And if people want to get up and do that, it's true. But I've also heard mutterings that this session should be extended. So after those who want to leave, if the panel is willing, we could go another round for the diehards.